All right. So it's great to be here. Thanks so much to the organizers for inviting me to talk to you today and to lead off Open Data Science Conference here on the West Coast. I'm Granger, and I'm one of the leaders of IPython and Jupyter. And I'd like to talk to you today about how Jupyter is a foundation for open data science. A bit about me. So I started to work on IPython in 2004. The creator of IPython, Fernando Perez, and I were classmates in graduate school at the University of Colorado. He started IPython in 2001, and between 2001 and 2004, I got to hear a lot about how Python was going to be the next great thing. At the time, in scientific computing, in 2004, I started to work with Fernando. In the summer of 2011, I locked myself in the basement, not quite literally, but didn't travel that summer, and basically wrote the first version of the IPython notebook, which has become the Jupyter Notebook. I continue as a core developer of IPython and a leader of IPython and Jupyter as well. I'm a physics professor at Cal Poly. What does that mean exactly? I spend about 20% of my time teaching data science and 80% of my time working on IPython and Jupyter. I'm also a board member of NumFOCUS. NumFOCUS is a 501c3 nonprofit that serves as an umbrella organization for a lot of the open source projects in this ecosystem. NumFOCUS is a really important part of this. Part of what we're finding with IPython and Jupyter is that it's not sufficient any longer for these open source projects to sort of be loosey-goosey from a legal and organizational perspective. We need a formal organizational structure to be a part of for fiscal purposes, for legal purposes. NumFOCUS serves as this umbrella. And if you like what you're seeing here this weekend at Open Data Science Conference, in terms of the open source tools, and you want to support that, one of the best ways you can do that is to give to NumFOCUS. There's a lot of needs that these open source projects have. Most of these open source projects that you'll hear about do not have significant amounts of funding. And there's very simple things like being able to travel to conferences, travel to developer meetings that these open source projects need. All that said, please support NumFOCUS and the different open source projects that are part of it. I want to begin by talking about the big picture of Project Jupyter. And this big picture begins with three observations. The first is this: computers are optimized for producing, consuming, and processing data. This is what we create them for. This is what all the engineers do when they're building computers. Humans, on the other hand, are optimized for producing, consuming, and processing narratives or stories. If you doubt this, just look at all the time that we spend on Netflix, watching movies, watching TV, playing video games, reading books. It's a significant fraction of the time in our lives where we're not sleeping. For code and data to be useful to humans, we then need tools for creating and sharing narratives that involve code and data. Visually, it looks something like this. And the point I want to make here is that without these narratives, the code and data is somewhat meaningless to us. It's difficult to make decisions based on it. It's difficult to extract understanding and insight from the code and the data. The Jupyter Notebook is a tool for creating and sharing computational narratives. And I want to illustrate this with a live demo. So for those of you who haven't seen it, this is the Jupyter Notebook. The Jupyter Notebook is an interactive computing environment in the web browser that allows you to write code interactively and then also build these computational narratives around that. And this particular notebook is running Python 3. And I'm just going to run some code here, load up matplotlib, pandas, numpy, read a CSV file into a data frame in pandas. So you can see the data frame here. You can see there's cities, the police force size, and then what look to be some percentages broken down by race. You can see there's 76 rows in this data set. You can look at some summary statistics. You can transform the data and then look at this transform and summarize data, and then use Seaborn to make a bar plot based on this data. Now, at this point, I think it's fairly safe to say that you would not be willing, based on what you've seen in this data, to put your life at risk, to make a decision that could potentially harm you physically or otherwise. And I would propose to you that what's missing here is the narrative. Not that when you see the narrative, you will become willing to do that, but you have the information, the context required to make those decisions. So what is the narrative in this particular case? So this data set comes from an article that was written in 538 in 2014 about the event in Ferguson, Missouri. And I just want to read you a quote from the article. In Ferguson, Missouri, where protests continued following the shooting of a teenager by a black police officer this month, more than 2/3 of the civilian population is black, only 11% of the police forces. The racial disparity is troubling enough on its own, but it's also suggestive of another type of misrepresentation. Given Ferguson's racial gap, it's likely that many of its police officers live outside city limits. Going back to the plot here, now we understand the context. What we're looking at here is a percent of police officers who live outside of the city, live in the cities they serve. What you see is that non-white police officers tend to live in town. They live with the people they're serving. White police officers, they live outside of town, which contributes to the racial problems that we're seeing both in Ferguson and elsewhere in the country. To summarize this, without the narrative, the data really does not mean much to us. So I want to jump now to a fairly rapid-fire tour of some exciting things. So 10 things you should know about Project Jupyter. First, Jupyter is developed by an all-star team. It's definitely not a one-person or a two-person show. First of all, we have an open source community of contributors that's many hundreds. At the center of this open source group of contributors is our core team. I've listed those individuals here. All of these people have made significant and sustained long-term contributions to the project and are really the backbone of our development effort. We also have industry collaborators at Google, Microsoft, IBM, Bloomberg, O'Reilly, Continuum, Rackspace, and Quantopian. It's a fairly significant effort these days, and I can't emphasize enough what a fantastic team we have to work with. Two, the Jupyter Notebook works with over 40 programming languages. When the notebook first came out in 2011, it was part of IPython. Notice the word Python there. It ran code only in the Python programming language. We quickly realized, though, that the abstractions we had built, namely the notebook document format and the message protocol that allows the web application to send code to be run to the kernel and then get back output. All of that was mostly independent of Python. And so over the following years, we generalized everything to support any programming language. And that is really what gave birth to Jupyter. Jupyter is now the new home for the language-independent parts of the project. IPython continues today as the Python kernel for the Jupyter architecture. You can see a full list of kernels here at this link at the bottom of this page. 3, Jupyter Notebooks render on GitHub. This conference is the Open Data Science Conference. Part of the openness involved in data science is being able to share your data and your code and your computational narratives with other people. And as of the spring of this year, if you are posting your notebooks on GitHub, they will render as a static HTML. So here's an example of a notebook, a very nice set of notebooks that Jake Vanderplas just posted this week. Here you can see them rendered as a sort of a human readable form of the notebook on GitHub. This enables open data science. A great example of this, one of my favorite, is from BuzzFeed News. Jeremy Singervine and John Templin are data journalists at BuzzFeed News. For each article they publish on BuzzFeed Feed News, they share their data and code on GitHub repo. The code is shared as Jupyter Notebooks, and they have an index here at BuzzFeed News Everything that lists all of the different articles they've written, and it's quite substantial. It's visit that for a second. Here you can see they've been doing this for a long time. I think it's a wonderful example of what being open in data science can look like. So for example, here's an article that they wrote recently. Immigration authorities are far more likely to jail you if you're Mexican. And again, this is on BuzzFeed. You don't typically picture BuzzFeed as being a rigorous, data-focused journalism outfit, and yet they're doing absolutely fantastic data-driven work here. Here's a repository in the notebook behind that. You can look at the data, you can reproduce the work they've done. This is part of what we mean by open data science. 4, with Binder, users can run notebooks hosted on GitHub. Binder is a new project being done by the group of Jeremy Freeman, who's a neuroscientist at Genelia Labs. And the idea of Binder is that you can go to mybinder.org, enter your GitHub repo, and then configure the dependencies required to run the code in the notebooks in that repository, either with pip, conda, or a Docker file. You click the build button, and Binder will automatically create a Docker image that has all those dependencies and the contents of that GitHub repository in a live Jupyter Notebook server. At the end of it, you get the code for a badge in your README. Anyone who clicks on Launch Binder instantly gets a live version of the notebooks, the code, the data, and all the requirements in the repository. Absolutely fantastic. Again, open data science. 5, you can also instantly spin up a temporary Jupyter Notebook by visiting tempnb.org. Let's do that. Click tempnb. I've got a notebook server. Anyone can do this from anywhere at any time. Notice all the kernels that it has pre-installed. Bash, Haskell, Julia, Python 2, 3, Ruby, R, Scala, and stuff. I should mention that's being hosted by Rackspace, and we are extremely grateful for all the support they're providing. Companies are building products that incorporate Jupyter Notebooks or kernels. Microsoft, Quantopian, Google, IBM, YHAP, DataIQ, Domino, O'Reilly Media, DataRobot, and Data. We're absolutely thrilled that these companies are adopting open source technologies. It allows users to work in contexts where they don't have to purchase products or services, and then seamlessly move that work to use products, commercial products and services when they need to, and go back and forth seamlessly. 7, JupyterHub brings Jupyter Notebook to teams and organizations. Most users, when they're using the Jupyter Notebook, install it on their local machine, and the code and data is on their local machine, and they end up just running on our Ludwig web server and running everything locally. That's fantastic in many cases, but for teams and organizations, you often want to co-locate computation with more significant compute resources and also data. JupyterHub allows you to install the Jupyter Notebook centrally on a large server or a cluster, and then allow all your staff to access the Jupyter Notebook through that in a centralized way. We're really excited about this and have a lot of exciting plans for the future. 8, the 4.1 release of the Jupyter Notebook is coming soon. Expect it in the following month. Some of the features it will have. First, multi-cell selection and actions. So if you need to move a group of cells, or cut, copy, paste, or run a group of cells, that will now be possible. For refactoring code, it will have notebook-wide find and replace. So if you want to rename variables or classes or functions. And there will also be an Atom-style command palette that gives you access to a wider range of actions in the notebook that are possible through the default keyboard bindings. 9, we're building a new front end. This is something we're really excited about. We've been working on for a while now. The tentative code name is the Jupyter Workbench. We're not quite sure if that name is going to stick. All the front-end code is being refactored into a set of loosely coupled NPM packages with well-defined models and views that you also can use in building your own custom apps that use these same building blocks. It's all based on a plugin system to make it easy for third-party developers to extend. So yes, you will be able to write NPM packages that simply get loaded into someone's Jupyter Workbench that can extend that environment. There will be a flexible layout system that will allow you to freely mix notebooks, text editors, terminals, output areas, interactive visualization, and dashboards in a single browser tab. We will also offer real-time collaboration. So if two individuals on different computers open two notebooks or text editors and start to edit those, the edits will be seen by all collaborators in real time. This effort is being funded by the Moore, Sloan, and Hemsley Foundations in collaboration with Continuum Analytics and Bloomberg. I'm extremely grateful for all the support that they are all giving us. This will start to show up in the first 2 quarters of 2016. 10, we are hiring. At UC Berkeley, we're hiring postdocs and a project manager. At Cal Poly, 3 hours south of here, we're hiring a UI UX designer, software engineers. This is really a fantastic opportunity to work on open source as your day job. I know there's a lot of people who spend their quote evenings and weekends working on open source, and we find that that only goes so far. At some point, it's really helpful to be able to work on this stuff full time. If you're interested in working with us, please come talk to me here at ODSC or contact me at LSMBG on GitHub, Twitter, and Gmail. So in the last part of my talk, I want to step back for a second and ask the question, what is data science? And how is the answer to that question related to Jupyter? The typical way of defining data science is to talk about the skills or knowledge areas or tools used by its practitioners. On the left, we see the standard data science Venn diagram from Drew Conway. On the right, we see one of the plots in the O'Reilly Data Science Survey that looks at the different tools that all of us are using. I want to ask, how useful is this approach? Well, minimally, it's helpful for hiring, teaching, and learning, right? We need to know as teachers, what should we actually teach? You need to know as possible students, what should I learn? And companies need to know what skills do we need in the people that we hire. But let's actually try to define something else using the same approach and see how it goes. How about, what's cooking? Well, what skills, knowledge, and tools are required? Well, skills, chopping, measuring, mixing, stirring, boiling, frying, operating a stove, purchasing ingredients, tasting, etc. Tools, knives, spoons, forks, cups, plates, pots, pans, measuring cups, oven, microwave, stove, etc. These things are all true about cooking. And yet, I would say they miss the fundamental point of cooking. So what is the fundamental point of cooking? Most of us would say, this is cooking. The end goal of cooking is to produce food that's nutritional and pleasant to eat. Right? It's something that you can smell, something that you can taste. Right? There's something here that's not captured when we're talking only about the tools and the knowledge areas required for cooking. The questions of cooking. Embedded in the end goal of cooking are a set of questions that capture its essence and must be answered by anyone attempting to cook. What meals are nutritional, pleasant, and affordable to eat? How long do these meals take to prepare? What do I feel like eating? What raw ingredients are required to prepare those meals? What is the cost and availability of those raw ingredients? What processes? And then, possibly, what tools and skills are required? I'd like to make an assertion. Data science is best defined by identifying the underlying fundamental questions common to its diverse realizations. What are those questions? Just some of them. I don't want in any way to claim that this is the definitive list of questions that define data science. I'm mostly thinking out loud here. How or where do we get data? What is the raw format for that? How much and how often? What variables are present in the data and what are their types? What variables that are relevant are not present in the data? What relationships are present in the data and how are they expressed? Is the data observational or collected in a controlled manner? What practical questions can we or would we like to answer with the data? How is the data stored after collection? And how does that relate to the practical questions we're interested in answering? There are many other questions that sit at the heart of data science. And what I'd like to propose is we begin to shift our thinking about data science away from tools and skills and knowledge areas being primary to questions, to fundamental questions being primary, and that the skills and tools and knowledge areas are secondary. They're a means to an end, right? So these questions are in many cases nothing more than the traditional scientific method. That's not coincidence. That's the science of data science. These questions can be pursued at any level. Children can pursue these questions. Undergrads, grad students, postdocs, professionals, even for pleasure, you can pursue these. These questions open a door for data literacy that extends far beyond current hyper-technical realization of data science. This is really important. Those of us here in this room cannot be the only ones who understand how to work with data and the fundamental questions about it. See, for example, if you're wondering, well, why is it important for other people to understand data? See the current national, quote, discussion surrounding global warming for vaccinations. For an excellent article on the dynamics of this in our culture, see this article by Chris Mooney and Mother Jones. It also allows for a healthy understanding of the relationships between data science and the skills and knowledge of its practitioners. The questions, again, are fundamental. Skills and knowledge are secondary. Implementation details. Different individuals will have different skills and knowledge. Everyone will not know everything. I think part of what's frustrating to me right now is that if you look at various hype about data science, you would think that you need to have 3 PhDs, an MBA, an MFA in visual design, and 30 years experience in building software to be a data science. I want to push back on this. I want to say no, you don't need that. You can start very simply by looking at these questions. And as you go, find the skills and knowledge area that you need. Most importantly, these questions are silent about education level, gender, race, academic degree, and years of experience. So how is this really related to Jupyter? The Jupyter Notebook is a tool that allows us to explore fundamental questions of data science with a particular data set of coded data in a manner that produces a computational narrative that can be shared, reproduced, modified, and extended. At the end of it all, those computational narratives encapsulate the goal or the endpoint of data science. The character of that narrative will vary from case to case. Sometimes it's predictive, sometimes there's inference or data generation or insight, etc. In the same way that a meal is the end goal of cooking, the questions that we explore in computational narratives are the end goal of data science. Thank you.